Corrosion allowance in corrosion design refers to an intentional increase in the thickness of a metal component or structure to account for the expected loss of material due to corrosion over its intended service life. In industries like oil and gas, chemical processing, and water treatment, where pipes, pressure vessels, and storage tanks are routinely exposed to corrosive substances, corrosion becomes an inevitable challenge. Corrosion gradually weakens metal equipment, reducing its structural integrity and leading to potential failures if not accounted for. One of the most effective ways to mitigate this issue is by incorporating corrosion allowance into the thickness of these components. Below are the key advantages of assigning corrosion allowance in the design of these assets. Below are the key advantages of assigning corrosion allowance in the design of these assets. Protection against corrosion. The primary purpose of corrosion allowance is to extend the operational life of equipment. With time, corrosion will cause a gradual reduction in material thickness. By including a corrosion allowance, engineers can ensure that even after a portion of the material is lost, the remaining thickness is sufficient to maintain structural integrity and safe operation. Protection in harsh environments. For environments with highly corrosive conditions, corrosion allowance is even more critical. It ensures that equipment can endure harsh operating environments while maintaining its performance and safety. Buffer against variability. Corrosion rates can vary depending on operating conditions, material quality, and exposure to corrosive substances. While engineers can estimate corrosion rates, there is always some degree of uncertainty. Corrosion allowance provides a buffer to accommodate variations in actual corrosion rates, ensuring the equipment remains functional even if the corrosion is more aggressive than initially predicted. Extended durability. The primary benefit of incorporating corrosion allowance is to extend the lifespan of the equipment. By adding extra material, the structure can endure a certain amount of metal loss due to corrosion while still maintaining its structural integrity. Meeting design codes. Many industries have strict regulations and design standards that mandate the inclusion of corrosion allowance. For example, the American Society of Mechanical Engineers (ASME) and the American Petroleum Institute (API) require that corrosion allowance be factored into the design of pressure vessels and storage tanks in certain environments. Incorporating corrosion allowance ensures that equipment is compliant with these regulatory standards. Consistent operation. Corrosion allowance ensures that pipes, vessels, and tanks can perform reliably even in harsh conditions, maintaining consistent pressure, flow, and containment capabilities over time. Design flexibility. Assigning corrosion allowance makes the equipment adaptable to a variety of environments, including those with high moisture, temperature variations, and chemical exposure. This allows the same equipment design to be used in multiple environments with minor adjustments, reducing the need for custom design. Longer inspection intervals. Equipment with adequate corrosion allowance can be inspected less frequently, as the extra material provides confidence that corrosion has not yet compromised the structural integrity. This reduces the cost of inspections and allows for more efficient planning of maintenance activities. Enhanced reliability. In industries with continuous operations, such as petrochemicals or power generation, reliability is critical. Corrosion allowance helps ensure that pipes, pressure vessels, and storage tanks perform reliably over time, reducing the risk of unexpected breakdowns that could halt production and result in costly downtime. Optimized inspection intervals. Equipment designed with corrosion allowance can be inspected less frequently compared to those without it, as there is more material available to corrode before the safety margin is compromised. This translates to savings in operational downtime and inspection costs. Satisfying inspection and safety requirements. Regulatory bodies often require periodic inspections of equipment to check for corrosion and other types of degradation. With a corrosion allowance, operators can demonstrate that their equipment is designed to tolerate a specified amount of corrosion, thus passing inspections and meeting legal and safety requirements. Enhanced reliability. In industries with continuous operations, such as petrochemicals or power generation, reliability is critical. Corrosion allowance helps ensure that pipes, pressure vessels, and storage tanks perform reliably over time, reducing the risk of unexpected breakdowns that could halt production and result in costly downtime. Satisfying inspection and safety requirements. Regulatory bodies often require periodic inspections of equipment to check for corrosion and other types of degradation. With a corrosion allowance, operators can demonstrate that their equipment is designed to tolerate a specified amount of corrosion, thus passing inspections and meeting legal and safety requirements. Maintaining structural integrity. Corrosion weakens metal surfaces, making them more prone to cracking, leaks, and ruptures. For pressure vessels and storage tanks, which often contain hazardous substances or operate under high pressure, any failure can result in serious safety hazards. By including corrosion allowance, the design ensures that the equipment remains safe to operate even as material is lost over time. Fewer maintenance shutdowns. Without corrosion allowance, equipment may need frequent repairs or inspections, leading to unplanned downtime that disrupts operations. By providing additional material thickness, corrosion allowance reduces the urgency for immediate maintenance when minor corrosion occurs, ensuring the equipment can remain operational for longer periods between inspections and repairs. Prevention of unexpected shutdowns. Corrosion-related failures can cause unplanned plant shutdowns, leading to significant operational and financial losses. By planning for corrosion, the likelihood of unexpected breakdowns is minimized, ensuring smooth and reliable operation. Predictive maintenance. Corrosion allowance enables asset managers to more accurately predict the remaining useful life of equipment. This helps in planning maintenance schedules, capital expenditures, and replacement cycles, leading to more efficient asset management. Prevention of leaks and catastrophic failures. Particularly in hazardous industries, the failure of pipes or storage tanks can result in leaks of dangerous chemicals or gases. Corrosion allowance helps prevent such incidents by maintaining the strength of the equipment. Preventing leaks and spills. Corrosion in storage tanks and pipelines can lead to leaks, which not only pose a threat to worker safety but also result in environmental damage. Corrosion allowance provides an extra layer of protection, reducing the likelihood of leaks and spills that could result in costly cleanup operations and environmental fines. Avoiding catastrophic failures. Pressure vessels and storage tanks can suffer catastrophic failures if corrosion is not properly addressed, leading to environmental damage, financial losses, and even loss of life. The extra material provided by corrosion allowance acts as a safeguard against such failures, providing a buffer that gives operators time to detect and address corrosion before it becomes critical. Minimizing early replacements. Equipment without adequate corrosion allowance may require premature replacement or repairs due to corrosion-related degradation. The added material thickness helps avoid this, ultimately saving on replacement costs. Lower maintenance and repair costs. Corrosion is inevitable in many industrial environments, but corrosion allowance minimizes its impact by delaying the need for repairs or replacements. By including corrosion allowance in the design phase, companies can reduce the overall maintenance costs associated with managing corrosion-prone equipment. Reduced replacement costs. Equipment with a well-planned corrosion allowance can last significantly longer, reducing the frequency of replacements and lowering overall lifecycle costs. Regulatory adherence. Many industries are required by regulations to factor in corrosion allowance in their designs to meet safety and performance standards. Incorporating corrosion allowance ensures that equipment complies with codes and standards set by industry bodies, such as ASME, American Society of Mechanical Engineers, or API, American Petroleum Institute. Assurance in high-risk environments. In industries handling flammable, toxic, or highly corrosive substances. Regulatory bodies often mandate the inclusion of corrosion allowance to minimize risk and ensure public safety. Resistance to unanticipated conditions. Even when the actual corrosion rate is higher than initially anticipated, corrosion allowance provides a buffer that ensures the equipment can handle more aggressive environments without immediate failure. Asset longevity and depreciation. Well-designed equipment that includes corrosion allowance will typically last longer than equipment that lacks it. This results in lower depreciation rates and improved return on investment over the asset's lifecycle. Reduced risk of overdesign. Without a corrosion allowance, engineers might overdesign equipment to ensure safety. Corrosion allowance helps companies manage financial risks by reducing the likelihood of unexpected failures for overly conservative designs, thereby saving material and reputational damage. Thank you very much for watching the video. Without a corrosion allowance, engineers might overdesign sharing or pressing bell icon for the video. A properly calculated corrosion allowance optimizes material use without the need for overly conservative designs, thereby saving material and production costs. Your testimony about the video content matters.